Okay, so in the first example, we have the segment addition postulate being represented here. So if JL is 19, so the whole length of this segment is 19. Remember your segment addition postulate. It says that the little segment JK plus the other little segment LK make up the entire length of this whole segment JL. So the entire length of this whole segment JL, we were told, is 19. So now we just have to substitute our values in for JK and LK. JK, they said, was x plus 3, and LK, so plus LK, which is 2x minus 5. And that side of the equation will equal 19. So we combine our like terms, x and 2x, which is 3x. Our positive 3 and our negative 5 is a negative 2. That equals 19. I'm going to add 2 to both sides of my equation. So I get 3x equals 21. Dividing by 3, I get x is 7. So that answers the first part of my problem. Then they ask for the length of JK. And you should be finding this anyway, because that's how you check to make sure that your x was found correctly. So JK was x plus 3. And we said x was 7. So we substitute the x back in. So 7 plus 3 is 10. And I'm going to go ahead and do KL as well. The length of KL is 2 times x minus 5. And we said x was 7. So 2 times 7 minus 5 will give us KL. 2 times 7 is 14, minus 5, that's 9. So JK is 10 and KL is 9. And to check our work, we want to make sure that our original segment addition postulate that we set up is true. Is JK plus LK equal to 19? Well, 10 plus 9 is 19. So we know we did it correctly. Okay, so I want you to try number 2. Draw a picture and solve for x. And then once you find x, go ahead and find HJ and JK. Pause the video and see if you get what I get. Okay, first make sure that you set your picture up like this. If you didn't have J in between H and K, then you're not going to have the right answer. Read this again and make sure you understand why J is here and the picture looks like this. You should have gotten x is 3, and then once you substituted x back in, HJ would be a length of 10, JK would be a length of 12, and we already knew that KH was 22. And to check our work, we see if 10 plus 12 equals the whole thing, 22, which it does. If you don't understand where I got this answer from, please raise your hand or ask a neighbor. All right, vertical angles. Vertical angles are formed by 2 straight lines. So we have a straight line here, and we have a straight line here. They are non-adjacent, so we have this angle, which exists alone from this angle. So that's what non-adjacent is. They don't share a common ray. And they're across from each other. So this angle is directly across from this angle. Vertical angles are congruent, so they have equal measures. So to make it simple, we just stick an equal sign in between them and solve for x. So 43 equals 3x plus 1. I'm going to subtract 1 from both sides of my equation, and I get 42 equals 3x. And I'll take 42 divided by 3, so I get x is 14. Now I know that I've solved for x, but I always want to plug it back in to make sure that this angle does in fact equal this angle. So 3 times 14 is 42 plus 1, which is 43. So 43 does equal 43. All right, we don't need that there. Go ahead and pause the video and try number 2. And you should get that x is 15. If you didn't get that, you're not sure how I did, please raise your hand or ask a neighbor. Then you have an angle bisector. An angle bisector, as we said, takes an angle and divides it into 2 equal angles. So it says that KN does bisect JKL. As soon as you see that you have an angle bisector, draw these 2 arcs here to show you that you only have to put an equal sign in between them. So you have 5x minus 25 equals 3x plus 5. Adding 25 to both sides of my equation, I get 5x equals 3x plus 30. Subtract 3x from both sides of my equation, I get 2x equals 30. Divide both sides by 2, I get x is 15. And I never want to stop there. In order to check your work in geometry, you always substitute your x back in and make sure that you get, in fact, two congruent angles. So 5 times 15 minus 25 should equal 3 times 15 plus 5. 5 times 15 is 75 minus 25, and 75 minus 25 is 50. So this angle 50 should equal 50 here too. 3 times 15 is 45, plus 5 is 50. So I know I did that problem correctly. Alright, we have supplementary angles and linear pairs. Remember, linear pairs are formed by two opposite rays. One ray is going this way, one ray is going this way, and they are adjacent, so they share a common ray in the between them. And a linear pair has a sum of 180 degrees. So that's what I do. I add these together, 75 plus 2x minus 5, and that equals 180 degrees. I'm going to combine my like terms, 75 and a negative 5, that's 70, plus 2x equals 180. I'm going to subtract 70 from both sides of my equation, so I get 2x equals 110, and I'm going to take 110 and divide it by 2 on both sides of my equation, so I get x is 55. Alright, go ahead and try the second one on your own. Pause the video and see if you get what I get. And you should have gotten x is 43. Alright, then we have complementary angles and perpendicular. As soon as you see this symbol here, this is your go-to setup problem. You see a number 2, you have this right angle here. You have two adjacent angles that form that right angle. So this angle down here is not going to have anything to do with your problem. So in order to solve for 1 and 2, we're going to set these two angles, these two adjacent angles, equal to 90 because they have a right angle that shows that their sum is 90 degrees. Alright, now I want you to pause the video for number 1 and number 2 and see if you get what I get. For number 1, you should get x is 8. And for number 2, you should have gotten x is 10.25.